Hello, everyone, and welcome to this video training on RabbitMQ. In this session, we will explore the powerful features of RabbitMQ's publisher functionality. Whether you are a beginner or an experienced developer, this video will provide you with valuable insights and practical knowledge to leverage RabbitMQ effectively in your messaging applications. Definition of a publisher. In the messaging context, a publisher refers to an application or instance responsible for producing and publishing messages. Publisher as an application or producer. The term producer is often used interchangeably with publisher to describe the role of an application that generates messages. Explanation of message routing and delivery. RabbitMQ, as a messaging broker, accepts messages from publishers and routes them accordingly. If there are queues to route the messages to, RabbitMQ either stores them for consumption or delivers them immediately to consumers. The destination to which publishers publish messages can vary depending on the protocol. For example, in AMQP 091, publishers publish to exchanges, while in MQTT, publishers publish to topics. STOMP, on the other hand, supports various destination types such as topics, queues, and AMQP 091 exchanges. The process of routing a published message involves ensuring that the message is successfully sent to a queue or topic. If there are online consumers available that can accept more deliveries, the message will be sent to the consumer. However, attempting to publish to a non-existent queue or topic will result in a channel-level exception with a code of 404 not found, and the channel on which the attempt was made will be closed. Long-lived nature of publishers. Publishers typically have a long lifespan, meaning they persist throughout the duration of their publishing activities, which involves sending multiple messages. Optimal approach for publishing multiple messages. To optimize the publishing process, it is recommended that publishers establish and maintain connections or channels, sessions, rather than opening a new connection or channel for each individual message. Connection and channel management. Publishers often open their connections during application startup to ensure continuous availability for message publishing. In some cases, publishers may even exist for the entire duration of their connection or the application's runtime. Publishers opening connections during application startup. During the initialization phase of an application, publishers commonly establish their connections to the messaging broker to prepare for publishing messages. This proactive approach ensures that publishers are ready to publish without delays when needed. Dynamic behavior of publishers in reaction to system events. Publishers can also exhibit dynamic behavior, starting and stopping their publishing activities in response to system events. For example, WebSocket clients utilized through WebStomp and MQTT plugins, as well as mobile clients, often employ this approach to adapt to changing circumstances. Let's talk about publishing differences in different protocols. Similarity in message publishing process across protocols. Regardless of the protocol used, the process of publishing messages in RabbitMQ exhibits significant similarities. Each of the 4 protocols supported by RabbitMQ allows users to publish messages, which consist of a payload, body, and one or more message properties, headers. Payload and message properties in message publishing. When publishing a message, all 4 protocols provide the capability to include a payload, which contains the actual content of the message, along with various message properties that provide additional metadata. Acknowledgement mechanism for publishers. Each protocol supports an acknowledgement mechanism designed to keep publishers informed about the success or failure of message acceptance by the broker. This mechanism enables publishing applications to track the status of messages, allowing them to proceed with the next batch of messages or retry publishing the current ones. Differences in terminology and message properties across protocols. While the overall process of publishing messages remains similar, the variations among protocols primarily arise in the terminology used and the specific message properties available. Different protocols may employ different terms and provide varying sets of message properties. Let us talk about publishing features of AMQP 091. Publishing process in AMQP 091. In the AMQP 091 protocol, messages are published on a channel to an exchange. The exchange utilizes a routing topology, which is established by defining bindings between queues, or source exchanges, and the exchange itself. Messages that are successfully routed are stored in the respective queues. Role of entities, channel, exchange, and queues. Within the AMQP 091 framework, the channel serves as the communication pathway for publishing messages. The exchange acts as the intermediary responsible for directing messages based on the defined routing topology. Queues store the messages that are successfully routed. Publisher confirms as the acknowledgement mechanism. The AMQP 091 protocol incorporates a mechanism called Publisher Confirms to provide acknowledgements to publishers. This mechanism allows publishers to keep track of the messages that have been accepted by the broker, ensuring the successful completion of the publishing process. Handling common types of publisher errors in AMQP 091. AMQP 091 includes features to handle various types of publisher errors. For instance, publishing to a non-existent exchange results in a channel error, which closes the channel and disallows further operations on it. If a published message cannot be routed to any queue due to the absence of bindings, and the publisher has set the mandatory message property to false default, the message is discarded or republished to an alternate exchange, if configured. If a published message cannot be routed to any queue and the mandatory message property is set to true, the message will be returned to the publisher. To handle this scenario, the publisher must have a return message handler in place to process the returned message, for example, logging an error or retrying with a different exchange. In this diagram, publisher, it represents the entity responsible for publishing messages in AMQP 091. Channel, publishers publish messages on a specific channel. The channel is used to communicate with the AMQP broker. Exchange, messages are published to an exchange. The exchange uses the routing topology, which is set up by defining bindings between queues and the exchange or between source and destination exchanges. Routing topology. The routing topology determines how messages are routed from the exchange to the queues based on the defined bindings. Queue. Successfully routed messages are stored in queues for consumption by consumers. Additionally, the diagram mentions the concept of publisher confirms, which is the publisher acknowledgement mechanism in AMQP 091. It ensures that publishers can track the status of their published messages. Publishing process in AMQP 1.0. In AMQP 1.0, the publishing process occurs within the context of a link. This protocol introduces the concept of links to handle various communication patterns between messaging entities. Context of a link in AMQP 1.0 publishing. AMQP 1.0 defines the link as the fundamental communication entity for publishing messages. Within this context, publishers establish and utilize links to send messages to the intended destinations. The link acts as the channel of communication, facilitating the transmission of messages between the sender, publisher, and the receiver, consumer, or other entities. In this diagram, publishing, it represents the process of publishing messages in AMQP 1.0. Publisher, the entity responsible for publishing messages. Link, in AMQP 1.0, publishing happens within the context of a link. A link is a unidirectional communication channel used for sending or receiving messages. The link represents the connection between the publisher and the messaging broker. Session. A session is a logical unit of work within a connection. It provides a context for one or more links. Connection. A connection represents the logical connection between the publisher and the messaging broker. Messaging broker. It represents the component responsible for receiving and delivering messages. The broker handles the routing, storage, and delivery of messages. Context of a link. The context of the link encompasses the specific settings, configuration, and attributes associated with the link. It includes flow control mechanisms, credit-based flow control, link properties, and other related settings. Please note that the diagram provides a more detailed representation of the publishing process in AMQP 1.0 and the context of a link, but it is still a simplified overview. The actual implementation and details can vary based on the specific AMQP 1.0 implementation, configurations, and features being utilized. Publishing process in MQTT 3.1.1. In MQTT 3.1.1, messages are published within the context of a connection to a specific topic. Publishers send messages to the topic, which serves as both a routing and storage mechanism. In RabbitMQ, a topic is internally backed by a queue. Connection and topic in MQTT publishing. Publishers establish a connection to the MQTT broker and publish messages to a chosen topic. The topic handles the routing of messages and stores them for future delivery. Publisher acknowledgement mechanism using pubak frame. When publishers choose to use quality of service QoS level 1, the MQTT routing node acknowledges the receipt of published messages using a pubak frame. This pubak frame serves as the publisher acknowledgement mechanism in MQTT 3.1. Retain messages in MQTT publishing. Publishers have the option to indicate that a published message on the topic should be retained, meaning it will be stored for future delivery to new subscribers. Only the latest published message for each topic can be retained. Handling of publishing errors in MQTT. Except for closing the connection, MQTT does not provide a specific mechanism for the server to communicate publishing errors back to the client. Publishers may need to rely on other means or protocols to handle and address publishing errors. Reference to MQTT and MQTT over WebSockets guides. For further details and comprehensive information on MQTT and MQTT over WebSockets, it is recommended to refer to the respective guides, which provide in-depth knowledge about these protocols. Publishing. It represents the process of publishing messages in MQTT 3.1. Publisher. The entity responsible for publishing messages. Connection. Publishers establish a connection to the MQTT broker to publish messages. Topic. Messages are published to a topic. Topics perform both routing and storage. In RabbitMQ, a topic is backed by an internal queue. Queue, internally. The topic is backed by a queue in RabbitMQ, where published messages are stored. QoS 1. When a publisher chooses to use quality of service QoS level 1, published messages are acknowledged by the routing node using a pubak frame. This serves as the publisher acknowledgement mechanism in MQTT 3.1. Retain messages. Publishers can indicate to the server that the published message on the topic should be retained, meaning it will be stored for future delivery to new subscribers. Only the latest published message for each topic can be retained. Publishing process in STOMP. In STOMP, simple text-oriented messaging protocol, clients publish messages over a connection to one or more destinations. These destinations can have different semantics when used with RabbitMQ. Connection and destinations in STOMP publishing. STOMP clients establish a connection to the STOMP broker and publish messages to designated destinations. These destinations can represent various entities or channels within the messaging system and may have different functionalities depending on their configuration. Server communication of message processing errors to the publisher. One of the advantages of STOMP is that it provides a mechanism for the server to communicate back to the publisher in case of errors during message processing. If an error occurs, the server can send a message back to the publisher to indicate the error or provide additional information. Publisher acknowledgements in STOMP using receipts. STOMP introduces a variation of publisher acknowledgements called receipts. Receipts are a feature enabled by clients when publishing messages. They allow publishers to receive an acknowledgement from the server once a message has been successfully processed. Reference to STOMP guides and specifications. For a more detailed understanding of STOMP and its usage, it is recommended to consult the STOMP Guide, STOMP over WebSockets, and the STOMP 1.2 specification. These resources provide comprehensive information and specifications related to the STOMP protocol. In this diagram, publishing. It represents the process of publishing messages in STOMP. Publisher, the entity responsible for publishing messages. Connection. Publishers establish a connection to the STOMP broker to publish messages. Destination. STOMP clients publish messages to one or more destinations. The destinations can have different semantics in case of RabbitMQ. Examples of destinations in STOMP can include topics, queues, or exchanges, depending on the configuration and semantics defined by the STOMP broker. Semantic handling. The STOMP broker handles the published messages based on the defined semantics of the destination. This can include routing, storing, and delivering messages according to the specific configuration and behavior of the destination. Receipts. STOMP provides a way for the server to communicate an error in message processing back to the publisher. This variation of publisher acknowledgements is called receipts. Clients can enable the receipt feature when publishing, allowing them to receive acknowledgement or error messages from the server regarding message processing. Routing in AMQP 091. In AMQP 091, routing is achieved through the use of exchanges. Exchanges can be thought of as named routing tables that facilitate the distribution of messages within the messaging system. Exchanges as named routing tables. Exchanges in AMQP 091 act as named routing tables. They define the rules and logic for routing messages to the appropriate queues based on specific criteria. Bindings as table entries. Within the exchange, the routing logic is established through bindings, which can be considered as table entries. Bindings define the relationships between exchanges and queues, determining how messages are directed and delivered. Built-in exchange types. Topic, fan-out, direct, headers. AMQP 091 provides several built-in exchange types to accommodate different routing scenarios. Topic exchange allows messages to be selectively routed based on matching routing patterns. Fan-out exchange distributes messages to all queues that are bound to the exchange. Direct exchange routes messages based on an exact match between the routing key and the binding key. Headers exchange routes messages based on header attributes. Additional exchange types provided by plugins. In addition to the built-in exchange types, RabbitMQ allows for the incorporation of additional exchange types through plugins. These plugins offer specialized routing mechanisms, such as consistent hashing exchange, random routing exchange, internal event exchange, and delayed message exchange. Enabling exchange plugins. To utilize exchange plugins in RabbitMQ, they must be enabled before they can be effectively used. Enabling a plugin grants access to the corresponding exchange type and its associated routing capabilities. In this diagram, routing. It represents the process of routing messages in AMQP 091. Publisher. The entity responsible for publishing messages. Exchange. Exchanges in AMQP 091 perform routing. They are named routing tables and hold the information for message routing. Exchanges have various types that determine the routing behavior. Routing table. Exchange. The routing table represents the configuration of the exchange, which includes the bindings between exchanges and queues. Bindings. Routing key bindings connect exchanges to queues and specify the routing key. The routing key is used by the exchange to determine how messages should be routed. Publishing unroutable messages to non-existent destinations. In messaging systems, it is possible for clients to attempt publishing messages to destinations, exchanges, topics, queues that do not exist. These unroutable messages occur when there is no valid route or matching destination available for the published message. Differences in handling unroutable messages across protocols. Different messaging protocols may have varying approaches to handling unroutable messages. The specifics of how each protocol handles these situations can differ based on their design and specifications. RabbitMQ's approach to handling unroutable messages through metrics collection, RabbitMQ, as a messaging broker, offers a mechanism to handle unroutable messages by collecting and exposing metrics. These metrics can be utilized to detect publishers that are attempting to publish unroutable messages. By analyzing these metrics, administrators or monitoring systems can identify and address such publishing patterns. Handling of unroutable messages in AMQP 091. In AMQP 091, when a published message cannot be routed to any queue due to the absence of bindings for the target exchange, the handling of unroutable messages depends on the publisher's configuration. Behavior with mandatory message property set to false. By default, if the publisher has set the mandatory message property to false, the unroutable message is discarded or republished to an alternate exchange, if one has been defined. This allows clients to handle situations where there are no bound queues or matching bindings for the message. Behavior with mandatory message property set to true. When the mandatory message property is set to true by the publisher, an unroutable message will be returned to the publisher. However, in order to handle the return message, the publisher must have a return message handler set up. This handler can perform actions such as logging an error or retrying with a different exchange. Introduction to Alternate Exchanges feature in AMQP 091. AMQP 091 introduces the concept of alternate exchanges, which is a feature that allows clients to handle messages that an exchange was unable to route. This feature is useful in scenarios where clients need to detect and handle messages that cannot be routed due to a lack of bound queues or matching bindings. It provides flexibility for custom routing semantics where specific messages can be handled differently while others are processed by a generic handler. Please note that the exact behavior and usage of handling unroutable messages may vary based on the specific configuration and implementation of the messaging system utilizing AMQP 091. Unroutable message handling. It represents the process of handling unroutable messages in AMQP 091. Publisher, the entity responsible for publishing messages. Exchange. Messages are published to an exchange, which performs the routing based on defined bindings. Routing error. When a published message cannot be routed to any queue, example, due to no bindings defined for the target exchange, a routing error occurs. Unroutable message handling. Depending on the publisher's configuration, unroutable messages can be discarded, republished to an alternate exchange, or returned to the publisher. Alternate exchange. Alternate exchanges is an AMQP 091 exchange feature that allows clients to handle messages that an exchange was unable to route. If the publisher has set the mandatory message property to false, default, the message is discarded or republished to an alternate exchange, if configured. If the publisher has set the mandatory message property to true, the message will be returned to the publisher, and a return message handler should be set up to handle the return. In MQTT, there is no specific handling for unroutable messages or setting up a queue for a new topic. Instead, publishers publish messages to topics, and the MQTT broker handles the routing and delivery of those messages to subscribed clients based on their QoS level and subscriptions. Multiple different destinations in STOMP. STOMP supports various destination types, allowing publishers to send messages to specific locations within the messaging system. Behavior when publishing to different destinations in STOMP. The behavior when publishing to different destinations in STOMP depends on the destination type and its existing topology. Topics/topic. When publishing to a topic that has no current consumer, the messages will be dropped. The first subscriber on the topic will trigger the declaration of a queue for it. Exchanges/exchange. When publishing to an exchange, it is essential that the target exchange already exists. Otherwise, the server will report an error. Queues/AMQ/queue. Publishing to a queue requires the target queue to already exist. If the queue does not exist, the server will report an error. queues /queue publishing to a non-existent queue in STOMP will automatically set up the queue, creating it for message delivery. Temporary queues /temp queue publishing to a non-existent temporary queue in STOMP will also result in the queue being set up, creating it for temporary message delivery.